Good evening, everyone. Today we are going to discuss on the topics traditional instrument versus virtual instrument, as well as graphical programming versus conventional programming. So, if you consider the traditional instrument is basically a device which is dedicatedly designed to do a particular functionality. If you consider an example for traditional instruments like ECG measurements, ammeter, voltmeters, whatever the instruments that we have taken, everything is dedicatedly designed to measure a particular functionality. But if you consider a virtual instrument, the virtual instrument which is empowered by the software LabVIEW, having the capability to reconfigure the instrument, and we can make use of the instrument based on our own. The basic examples that we discussed for traditional instrument as well as virtual instruments. Now we are going to compare the various features between the traditional instrument as well as virtual instrument. First, if you consider the quality, the traditional instruments, if you keep on using it for aging, whatever the instruments, if we keep on using it, the quality, that is, the usage, keep on using the instrument will reduce its life. But if you consider the virtual instruments, everything inbuilt within the software, so the quality will be more. The next one is the design cost. If you want to create a traditional instruments, we need to connect different types of hardwares combinedly to perform a particular function. But in this case, the design cost is very less, because in traditional instruments we have to design both the front panels, the display segments, the controlling segments, measuring segments, everything individually, and we have to combine together. But here the design cost is very low. The next features is the traditional instrument is vendor defined. The meaning of vendor defined is we have to give the specification to the designer, what are all the things the instruments can do. For example, if you want to measure an ammeter, if you want to design an ammeter, we have to specify the range of the ammeter, the range of the current that it can measure, the type, that is, it has to measure AC or DC, what type of coil we have to choose, everything we have to give a specification. But in virtual instrument, it is user defined. We can change its value based on the need. The next one is, in traditional instruments it has fixed functionality. And that I have already mentioned, the voltmeter will measure only the voltage, the ammeter will measure only the current. But here we can provide the flexible functionality, where we can customize each and every instruments based on our application as well as our need. The next one is the it requires displays, knobs, etc. Suppose if you want to change a particular value, we have to keep on changing its knobs, as well as the corresponding reading will be displayed in the LED. But here it uses the computer, so the reliability of the instruments will be more, and it provides more interactive with the user, which makes our work much easier. Then on the other hand, the traditional instrument is very large in size. The complexity of the instruments will goes on increasing, whatever the requirements that we add together to build it in a single system. But in virtual instrument, it is small in size. Also, the traditional instruments requires external power and it consumes more amount of power. But here it is a computer, it requires very less power for whatever the instruments that we are designing, because all the instruments is running with the help of LabVIEW software. It has low power consumption, as also low computational powers, because the traditional instruments having the capability to display some values, but it don't have the computational powers. the user has to collect the data and they have to manually calculate the computations, and they have to finally comes to the conclusions. But in virtual instruments, it has a high computation because the processes and the technology will keep on increasing, so we can put together everything within a software. So the software has large number of mathematical and engineering related functions, so we can easily perform the computation of whatever the data we need. And at last, it uses hardware for data processing, but virtual instrument uses software for data processing. So within this, we came to know what are the traditional instruments do, what are the conventional instruments can do. Next, we go for conventional programming. If you consider the programming, the virtual instrument is more rely on the graphical programming concept. So if you want to design any instruments using lab, we have to understand what is graphical programming. So before going into the graphical program, first we have to know what is conventional and how the graphical programming is differ from the conventional programming. So if you consider the conventional programming, it is the olden programming language where the user keep on writing the code for each and every task that it does. Examples of conventional programming is C, C++, Java, Python, everything. Because it is a manual process where the programmer will keep on writing huge number of codes to thousands and thousands of lines to perform particular applications. So it took lots of time, and it takes more mm, time to debug. So the conventional programming is how been built computer for over a century. Like if you want to filtering your photos, we have to write a code that will with more specifications. Based on that, it will identify it. But the graphical programming on the other hand, it uses graphical user interfaces. That is, uh, instead of writing large number of codes, just we keep placing an icon. That icon itself programmed backend, so it will does all the functions whatever the written in that codes. So graphics programming offers more intuitive options and less bottlenecks while designing the applications. It will also be more effective way to introduce computer programming to visual listeners. So if you compare the conventional programming as well as graphical programming, that the main difference between the conventional programming and graphical programming is the way it will represents the data and it will process the data. Because the conventional programming, if we keep on writing the text based codes, while but on the other hand, if you consider the graphical programming, it is a visual elements. The conventional programming is more suitable for tasks that requires complex logical and computations, while it is used for spatial representations. Then if you consider the conventional programming, it requires deep understanding of syntax, tasks, where to call the data, where to represent the data, everything. But the conventional programming, it is easily accessible without the programming knowledge. So here are the comparison between the text-based programming as well as the graphical programming. If you consider the text-based programming, the syntax is the most important. So everything we have to write based on that syntax only. But in graphical programming, the syntax is just a knowledge. Even the person who doesn't know the programming concepts can easily program whatever the need only with the concepts. In graphical programming, the execution of the program is from top to bottom. It will execute one by one from top. If there is any mismatches between these two lines, it won't execute further, but it is left to, but in convention graphical programming, it is left to right approach. To check the error in the text based programming, we have to compile and execute the program. After that compiling and execution only, it will shows the errors. But In graphical programming, the errors will be indicated as a broken wires if we are mismatching the connections. So the front panel design, if you want a front panel design, it needs additional codes. So we are writing a code for backend. If you want to bring the design in the screens, we have to write additional codes as a front panel. But in graphical programming, both front end and back end is simultaneously programmed, so it will reduce much of coding time. Then if the text based programming is non-interactive, but the graphical program is more interactive, in the sense we are not known what we have to read each and every line, and the flow, how, what is the way he is writing the program, everything we need to understand. It's difficult, but in graphical programming it is highly interactive, so we can easily understand the program flow as well as the design. The text based programming, where it is the conventional method of programming, it is the data flow programming. So the logical error finding is easy in conventional program, because if you compile the error, we can easily identify the logical variations. But in graphical programming, the logical error finding is quite complicated. The in text based programming, the program flow is not visible, but in graphical programming we can easily view where the data, how the data is moved, when the data is moved easily. Again, it is a text based programming, it is icon based programming, because it is, we have to write codes in graphical programming. We have to pick and place the icons. The icons will perform the required operations whatever we written in the code as a text based programming. So passing parameters to the subroutines is difficult, but here it is very easy in graphical programming. Within this, we conclude whatever the things that we have decided, but that we have discussed in this is conventional programming versus graphical programming, traditional instrument versus virtual instruments. Hope this